Hello, everybody. We're going to talk a little bit about buoyancy. I'm going to have my grandson Charlie draw a pail with water in it, a clear pail. Okay, and now put the water level. Okay. Now, if you had a ball that was heavier, now by heavier I mean more dense than water, where would that ball be? Is that the water?
Yes.
Okay. All right, now get a different color.
Oh, there. That's fine. What color?
A red, maybe a red ball. All right, now if the red ball is heavier than water, more dense than water, it'll be on the bottom. So put the red ball on the bottom. Now, make the water level so you have a ball that's very, very.
This is a little light.
Oh, okay. Now, if you hit that, you can get the different colors.
I can hit this. No, I can't.
All right, now let's make a yellow ball, maybe, or.
Okay.
All right, now.
Let's just say it's full.
All right. Now let's get a yellow ball, and the yellow ball is like the ping pong ball. It's very, very light. So it's gonna float, and it's gonna float very high in the water. It's gonna be practically mostly above the water, but just a little bit below. And now let's say we have another ball that's just a little bit less dense than water. Just a little bit less dense than water. So it's going to float, but it's going to be pretty close to mostly submerged. That's good. Now, how much the ball floats or sinks, the degree to which it is submerged, depends on its mass, but also its volume. And it really depends on the ratio, or the dividing the mass by the volume to get the density. The density of water is 1 gram per cubic centimeter, or mass divided by volume equals density, equals D. As I said, D for water, DH2O, equals 1.0 gram per milliliter.
The 2 sevens.
Yeah, that's right. Equals 1.0 to 2 significant figures. 1.0 grams per milliliter. Gram/ml. And remember, a milliliter is the same as a cubic centimeter. Okay, you might have to put it just a. That's good. Now, if you had ice, for those of you who watched our video the other day, for ice, the density is actually less than that of liquid water. Solid ice expands when water freezes it. Let's say you had some ice formed from water.
What color should I make the
I
ice?
guess blue.
Let's make it lighter.
All right. So if you had ice, the density is about,
Then it would expand.
it expands. And of course, you saw in our demonstration of that the glass, when we put the water in a glass bottle, a little glass bottle, it completely.
High. And maybe even out of the bottle.
Well,
See,
now that doesn't mean it floats at the very top. There's a little
out
bit.
of the bottle.
Some of it's submerged. It's not like it's completely, because the density of ice.
Some of the bottle breaks.
Some of the ice will be below the water level, and some of it will be above.
It breaks. It will break
If it's in a sealed bottle, it will break.
if it's in a sealed bottle. So let's.
Now we're going to do a demonstration today, a regular video, to show that liquids other than water do not expand when they freeze and do not therefore break the bottle. Okay? So if you had a liquid like, let's say isopropyl alcohol, and you froze some isopropyl alcohol, in fact, the isopropyl alcohol frozen, solid isopropyl alcohol, would sink in the liquid isopropyl alcohol.
Let's say. Opposite as well, it could also break the top.
Right.
See,
Now wood.
break the top and put it.
Shall we bring it to a close?
Oh. Or I can loosen the top a little.
Okay.
That.
Um,
Not that high up. It's still sealed, but it's loose.
But it's loose. Okay. Okay. So thank you for attention.
Now, what about the density of ice?
Okay, the density of ice.
Wait.
We looked it up on Wolfram Alpha. It's 0.0.
I'll make a cube.
So the density of ice.
D equals
0.916.
0.916.
Put the units underneath. Grams per milliliter or grams per cubic centimeter. Generally, they use the term milliliter for liquids when they're talking about the volume of a liquid, and cubic centimeter for solids. But either one is appropriate.
Oh, can I say something? Or are you recording?
We're recording. And that should be capital L.
Capital L.
Small m, capital L.
Small m,
Okay.
capital L.
You could actually calculate mathematically how much, let's say 10 milliliters of water. Can I show them how to do that? You can calculate. How do I get back to this page? let's say you had 10 milliliters of liquid water.
The same way you keep going with the other page.
And you froze it. How would we find the volume of the ice? Okay, that's an interesting thing. The volume of the ice would be, you're doing a conversion, 10 milliliters of the liquid times
You need
times 1. How do we get out of that?
you need to click.
Milliliter for every 0.916 grams milliliter of liquid water. So if we divide that, we would get, I don't like the way I did that, but 10 divided by 0.916 equals 10.9 milliliters. So it increases by 9%. Okay. Now that's a significant change, and the reason that ice has a larger volume than the same mass of water is because the ice, the structure, the molecules are further apart in the ice. You'd have to look at the crystal structure of ice to make a comparison. I think we should stop it now.
And the molecules are further apart.
Fortunately, you can't get to click on that page, I guess.
Like, and the molecules of water aren't as far apart.
Right. Okay, I think we'll stop there. So let me see if we're actually recording this. I'm going to press the F1 button.